Next up, we're going to talk about independence and the multiplication rule. Vocabulary you need to know. Independent is events E and F are independent if the occurrence of E in a probability experiment does not affect the probability of event F. They are said to be dependent if the occurrence does actually, in fact, affect the probability. So obviously, you can't be both independent and dependent at the same time. Consider the following. You flip a coin and record the results. Is this independent or dependent? Well, the first flip happens. It has no variance on the second flip, so therefore these are independent. Consider the following. Are the events earned a bachelor's degree and earns more than $100,000 per year independent? Well, quite a few people who have bachelor's degree, well, not quite a few, but some of the people who do earn more than that, and those opportunities are only enabled because they have their bachelor's degree, so these are dependent. Like, for instance, if you want to be a teacher, you have to have a bachelor's degree, and some teachers can make upwards of $100,000, so that's what I'm referring to. Consider the following. 2 24-year-old male drivers who live in the United States are selected. Are events male 1 gets a car accident during a year and male 2 gets a car accident during the year independent or dependent? These are independent events because they are 2 randomly selected people, and the first person crashing has no variance on the other person crashing during the same year. Unless they crashed into each other, I guess, but 2 events are disjoint if there are no outcomes in common. This also means that we know if one or more of the this also means we know that if one of the events occurs, the other event did not occur. Independence requires that one event occurring does not affect the probability of the other one event occurring. Knowing this, 2 events that are independent cannot be disjoint. And I have linked a video on the help page of my website to show the difference between the two. If you go to our stats page and look at this, there's a very good video that describes all of this, and I think it'll help you understand if you're struggling to understand what that slide says. Consider the experiment of rolling a die. Let E be the event rolling a die and F be the event rolling an odd number. We can see that the events E and F are disjoint. Okay? Obviously, you roll an even number, you can never roll an odd number. Now we are told the outcome of the roll will be even. What is the probability of event F being odd? Well, the probability of event F is 0 now because we know what the outcome is going to be. And since we know what the outcome is, it changes the likelihood of it happening, so it cannot be independent of each other now. Because obviously the probability changed. It's dependent on the fact that we know what was rolled. It was an even instead of an odd. Now, the multiplication rule works as follows. If E and F are independent events, then P of E and F is P of E times P of F. So, suppose you flip a coin twice. What is the probability you obtain heads on both flips? What is the probability you obtain head on the first and a head on the second? Okay, so let's look at the sample space. Okay, we're going to do this by, we have probability of heads. That's the first one they mentioned. So what's the sample space? So the sample space for this is going to be heads, tails, tails, heads, and tails. Sorry, ran into my button at the top. Okay, so we've got that, and so the probability of heads is simply 1 out of 4. Now the probability of heads, and then probability of heads again, well, you either get heads or tails, and you get heads or tails. So this is a 1 out of 2 and a 1 out of 2, and so if you multiply this together, you get 1 out of 2, which is 1 out of 4. So you can see how that it works. It is consistent with what we said earlier. In the game of roulette, the wheel has slots 0, 0, 0, double 0, and 1 through 36, meaning there's 38 numbers. A metal ball rolls around. What is the probability the ball will land on the slot number 17 2 times in a row? So we're going to put things in boxes. So we want to know probability of 17 in roulette. Okay. Well, we said there is 0, double 0, and 1 through 36, meaning there are 38 numbers. Okay. So the chance that you get 17 is 1 out of 17 for the first spin. Okay. Or, oops, sorry about that. 1 out of 38 for the first spin. Okay. Now, since this is independent of the next spin, if we multiply these, what is the chance you get 17 the second time? It's 1 out of 38 again. Okay, so from here, we do 1 divided by 38. Sorry, let me do this better. 38 times 38 is 1444. That's 1 out of 1444. So 1 divided by 1444. As you can see, this is 0007, which is our best rounding we do for decimal places. So what that means is there is a 0.07% chance, meaning it's less than 0.07% Okay, so it's a very low chance that this happens. Next one, P of E multiplication rules if there are n independent events. As you can see, all we're going to do is end up multiplying all of them together. It's not any different than, oops, I didn't mean to move that. It's not any different than if they were just 2. There's just more of them now. The probability that randomly selecting 24-year-olds will survive is this. What is the probability that 3 randomly selected 24-year-olds will survive the year? Okay, so actually, let's start a new video for the rest of this, because this one's getting kind of long. So I'll restart this and we'll pick up where we left off. Thanks.